magnifies this and widens this definition and says that green building is nothing but a practice of creating different structures or processes using which that are environmentally responsible for the building's complete life cycle. That is starting from siting, designing, construction, operation, maintenance, renovation, and reconstruction or deconstruction. So net zero energy building or energy efficient, again, I just wanted to tell you this. Please do see standardized definition of net zero energy building starts that net zero energy building is an energy efficient building. So if a building is not an energy efficient building, it can never be net zero energy building. So what I'm trying to tell you is, for a building, if you are using your energy resource, satisfying your energy resources using a diesel generator, so that your net bill is coming to be zero, it is not a net zero energy building. I hope I have made myself clear. Okay, that's what I wanted to tell you. If you are using diesel generator sets, small gas-based turbine power plants or whatever it is, so that is not your net zero energy building. So it has to be energy efficient building. Green building widens it. So it's not only about energy, it is about soil, environmental impact, water, pollution, air, each and every. If you say, if layman terms to understand, optimal usage of 5 things: Jal, Vayu, Prithvi, Akash. Jal, water; Vayu, air for ventilation purpose; Prithvi, the soil I talked about; Akash, sky for lighting purposes. Okay. Like you can see that also in our civilized Indus Valley civilization or our old constructions. In Pondicherry, we have Aurovilla. In Delhi, we have Lotus Temple. All of these majorly talk about. Now, let us talk about smart building again. The smart buildings, the definition that I have taken is from the Oxford Dictionary and also from the Sinopolis IEEE magazine, where a smart building is nothing but installation and uses of advanced and integrated building technology systems, which are nothing but ICT technologies only, information communication technologies. So now that we have understood, started from a very basic energy management, sustainable energy management, AI techniques, AI-based techniques, what are the techniques that are available, smart grid scenario, futuristic power grid scenario, modern power systems, building energy systems, and net zero energy building, green building, and a smart building. Now let us understand where does the buildings to grid integration focuses in. Whenever we say buildings to grid integration, that means it is bi-directional flow of power, bi-directional flow of communication also. So it is assumed that whenever you talk about building to grid integration, there is a bi-directional flow of consumption communication as well. That means, as per the definition of smart grid, any appliance that you are working on, for example, I majorly work on inverter-based air conditioner system. You may majorly work on smart refrigerator. Someone may work on smart LED lights. All of those services or appliances can be controlled by the utility. Okay, and which is true also. I'll give you an example. This you can, I can apply, I can download certain apps in my mobile through which I can control, switch on, switch off, and control my air conditioner system, my TV system, right? I can have an app, develop an app controlled by the utility, which controls that app. So I can integrate that feature. So mobile app can be the, see, how we are doing banking, we give the control to Paytm. We say, okay, I link my UPI with you and I am paying someone using mobile. In the same fashion, can you do it for control in order to regulate your frequency and voltage? That is simple, the research. For it, the concept is, this concept has already come up at a report developed by US Department of Energy through a partnership with Navigant Consulting, where they talk about grid interactive building energy systems. This grid interactive building energy system again has a very technical definition to it, that it is again an energy efficient building block. It is very necessary. This point is very, very necessary that it is an energy efficient building with smart technologies, that is ICT based technologies, characterized by the active use of distributed energy resources, those resources which are connected at a voltage level less than 33 kV to optimize energy usage for grid services. Grid services means they are providing power system regulation, either frequency regulation or voltage regulation. Okay, so there is one box. One side of it is talking to the grid, another side of it is talking to us. Okay, providing us the needs, the thermal comfort, the visual comfort, the ventilation comfort, the corona-based comfort, the PM 2.5 pollution comfort. Okay, pollution comfort means reducing that pollution. All of this happening in a cost optimal way. So cost reductions are also coming into the picture. How do we develop it? Initially, I told you that there is no what we call it as universal structure for building to grid integration because it is comparatively a novel concept. So we usually, I'm providing you usually the point that I consider in my study. We start with the modeling first. Three aspects. One can be a white box modeling. That means you are not doing any experiments, but you are completely dependent upon mathematical equations, textbook equations, theoretical equations. Such models are very accurate, but they demand large computational power. Then we have black box modeling. Black box means you don't know anything. They're completely black. You don't know anything about the model. You just give them experimental inputs to get the experimental outputs. You do regression-based analysis to give a output-input relationship. They are very simplistic models, but heavily data-driven, and they are least accurate. Then we have gray box model, where we use theoretical equations, certain parameter values, we predict using some optimization-based algorithm. I'll show you, I have an applied energy paper to it. And then we, after the modeling, we do the comfort and energy optimization because, as I told you, we are not only talking about energy management, but Smart Grid says that one thing that my research is challenging is not the definition of energy efficiency, net zero energy building, or smart grid. Talks about my comfort, boss. See, I'll give you an example. This is 4th of December. The temperature outside is 13 degrees or 12 degrees Celsius. It is not expected from any of the occupant that the occupant will switch on the AC. Okay. But the contract with me, the consumer, and the electricity service provider is in such a way that even in the 25th of December, if I switch on the AC should work, boss. నేను స్విచ్ చేస్తే ఏసీ పని చేయాలి. అది డిసెంబర్లోనైనా జూలైలోనైనా. The utility can penalize me for doing this, but the work should be done. So occupants' needs should be taken into consideration. That's what major, if you call it as a practical gap that we are trying to address through buildings to grid integration. So after developing the building interaction modeling, it is necessary that we develop grid interaction model. So we majorly use of swing equation, load frequency control transfer function model. How do we implement and evaluate it? Using Bellick controllers or other controllers, fractional PI controllers, you can make use of them, work on their robustness, work on the least worst case scenario and develop PI controller for worst case scenario so that it works on the optimal scenario. And do fault detection and diagnosis. I won't be able to provide any information about fault detection and diagnosis because this will only be provided if I get funding for hardware implementation. So we are working on that project. So as soon as we finish it, I will be able to provide you with much more information. Now, if we talk about building energy modeling, it is necessary that we understand what are the parameters that are being used for the building energy modeling. So these are the main significant parameters that are being majorly considered for the mathematical equations. Uncontrollable parameters are those parameters where my control algorithm will not be able to change its patterns or magnitudes at what time that magnitude is also coming. Controllable parameters is the control algorithm will be able to change the parameters, values, and also the times at which those values are attained. One another thing, I request again, if any one or two of the participants, if you are listening to this lecture or talk, there is one, I always ask this, there is one limitation here. There is one parameter where I have considered as uncontrollable, but they are controllable. So there is one mistake, if I can be blunt. There is one mistake in the slide. I request the participants to tell me what that mistake is. One of the parameters in this slide I have considered as uncontrollable, but they are controlled. They are not uncontrolled. Can anyone care to venture a guess? Anybody? Or you may put it in the chat box if you are not able to control it. Anyone? I repeat my question again. There is one parameter which I have taken as uncontrollable, but that is actually controllable. Anybody? You can read it out. It's a very simple aspect also. Like which of the parameter where you believe I have taken as uncontrollable but should be controllable. That means that you can develop algorithm for thermophysical properties. Thank you, sir. Can you tell me why, sir? Any idea?
Sir, it depends on the materials which we use, sir, like construction point of view.
Yes, yes, yes. Very good, sir. Thank you. Thermophysical properties of the components I have taken as uncontrollable because the control algorithm which I have developed should be universally acceptable. For example, if I develop the control algorithm which works fine for Chennai, it should work fine for Kolkata. It should work fine for a building in Mumbai as well. Thermophysical properties are majorly thermal and physical properties like thickness, thermal conductivity, resistivity of the materials which we use to build the construction. Now that data will be given to us, then only the control algorithm will work. So the control algorithm input will be thermophysical properties. So the control algorithm will not be able to change that thermophysical properties. It will not change the input. So it will not be controllable. It is the input to the control algorithm. Hence it is uncontrollable, sir. Did you get my point, sir? So if you see here, actually, interestingly, solar radiation I have taken as uncontrollable, but it is controllable. Let me tell you why. Let me tell you how. If you look inside wherever you are sitting right now, even if you are sitting in a car and watching this, geometrically we are sitting inside a cuboid. So we have 4 walls around us. There is one roof, there is one floor. We also have doors. At the same time, we have windows. The windows have curtains. In the coming smart home scenario, where I gave you the definition of smart building, the curtains can be integrated with blinds and the opening and closing of curtains can be controlled. Right? If you have seen certain videos of Google Alexa, Google's Amazon Alexa or Google Smart Home, you will understand what I'm trying to tell you. So if you can control that opening and closing of the curtain through a window, you can control certain aspect of solar radiation coming inside your building space. Now, why is that important? All of us know, as I have been pointed out many times, several times during the course of my lecture, that I am majorly focusing on air conditioner systems. So if we are opening the window blinds, the solar radiation which comes in will increase the heating inside the building and will increase the load on the air conditioner system. So this becomes a very interesting aspect. So that is why few of my research scholars are considering this as an controllable and using machine learning algorithms to understand what is the pattern of opening and closing of the blinds. Okay, I hope I have made myself clear. So the solar radiation I have taken as uncontrollable is a mistake, but this I'm showing you is a paper that I published in RSCR in 2016. So we are working now where we are making this as controllable scenario, where the solar radiation will be controllable. After developing the parameters, as sir has correctly pointed out, we make use of the thermal physical properties and develop thermal resistance and thermal capacitance. So what we are doing is, we are developing building energy models in terms of resistance capacitance networks. How we develop is just like a concept of transducer, where every physical parameter we are calibrating it, converting it into a equivalent voltage or current signal in a very for digitalization and for metering. In a very similar fashion, we use thermal electrical analogy. As thermal energy or heat flows from higher temperature region to a lower temperature region, in a similar fashion, electric current flows from a higher potential point to a lower potential point. So in any network, the voltages nodes will become the temperature nodes and the current flow will become the heat flow, right? So that is why we make use of thermal resistor, thermal electrical analog. One more thing where machine learning based aspects are coming or AI based aspects are coming in are occupants comfort centric approach or occupants comfort centric control. Can we, I'll tell you in the nutshell, can we integrate or can we operate air conditioner without a remote control? That is this research aspect. I'll give you an example. For example, my cabin in NSUP, I have an air conditioner system. We are in a regular service, so we understand for that for many years, for several years, that will be my cabin. There will be a certain amount of pattern of how I use my air conditioner system. Where I'm going, I'm switching on, I'm making use of the remote control, switching it on, switching it off, changing from 24 to 26, sometimes 16. I told you that mobile can also control the air conditioner system. Mobile has Bluetooth, using which it is doing that. If I can tap my behavioral pattern using some computer-based algorithm and make use of my mobile. That means if the mobile, and majorly we have mobile with us all the times. Very sad, but even during washrooms, we take our mobiles with us. Now, if my mobile is entering in the cabin, that means I am entering in the cabin, and the control of the thermostat, which is controlling, regulating the air conditioner temperature, is happening in such a way that it is talking to my mobile rather than certain actuator, which is the remote control, losses are getting reduced. And the same time, my mobile is also being controlled by the grid. So for example, in June afternoon, I enter my room, I want the air conditioner to operate at 16, but grid says there will be a large amount of peak demand happening. So don't operate at 16, operate at 24, it is automatically doing it through my mobile. That is occupants comfort centric control based buildings to grid integration. So how we can integrate humans through technologies for the comfort based control. That is OCC, occupants comfort centric control, which again is an AI based building sustainable building energy management system, where we not only talk about occupants and building, but we also focus on IEQs. IEQ is indoor environmental quality. So the problem statement through which the research statement through which we are doing OCC is ensuring occupants' comfort as well as the energy saving. So these two becoming the main objectives for the optimal building energy usage. So this is my baseline scenario that I have taken into consideration. And this is hardware in loop test bed, which we are developing in my cabin at NSUT, where we will be installing all these wall mounted sensors and everything, and that split air conditioner system will operate according to my mobile. And that mobile will be getting the control commands from the Opal RT. That is the microcontroller which we will design for frequency regulation. This is the working flow chart we have developed. If anybody is interested, I encourage you to have a discussion and we can work on this. So coming back to the building energy modeling, which I told you will be having the RC networks. Now, the main gap is what should be the value of R1, R2, R3, C1, C2. Large number of research studies have bifurcated equally to the thermal resistance. Again, I showed you a slide where RTH and CTH calculations were done based on thermophysical properties, but that is not always true. So what I have done is we have developed a reduced order modeling and parameter estimation identification technique, where we make use of FMINCON, there constraint optimization algorithm, in order to develop the R values, C values of the thermal resistance and capacitance network. As I told you, we are sitting inside a cubert, so every wall will have a 3 resistance to capacitance network. Why 3 resistance to capacitance? Because it's a second order model. And the window will have a 2 resistance 1 capacitance network, because the temperature or outdoor weather can easily pass through the glass as compared to the wall. Again, we develop a model order reduction technique. That's why the name was reduced order model. So I develop a building energy model. Now I have to develop a HVAC model, which is heating, ventilation, air conditioning system. So I have taken an all seasonal HVAC model and developed it using a PI controller, reduced it to a second order to a fourth order model, and developed it as a state space function. It is a MIMO system, so it will not have only one transfer function. It will have 3 transfer functions for perturbations in output coming from the air conditioner systems, perturbations in the outdoor temperature, and perturbations in the ventilation. This is considering any leakage if it is happening in the system. If you want to see the outputs, I encourage you to go through the reference papers or research paper. Majorly in the coming decade, my major focus is on developing net zero smart energy tool, which will considering the engineering, social, socio-techno-economic aspects for a prosumer-based systems, where we are considering not only the energy technologies, but also the environmental aspects. The environmental aspects I am lacking. I'll be starting with the research scholar, which will be coming to us in the December January admissions. So thus, it is very much important that we understand and develop for a sustainable energy management and smart grids using AI, where we are able to integrate the renewable energy generation in order to make the grid stable. We make use of the virtual inertia. We also enhance the demand side intelligence, use smart technologies. We ensure social equity through peer-to-peer energy trading. Actually, this is majorly on peer-to-peer energy trading, where all the stakeholders of any economic class are getting benefits from P2P energy sharing, and thus we develop smart grid. See, smart grid is not like a smartphone. You cannot go to the market, change our phone. You cannot go to the market and change our grid. We have to convert or transition our existing grid into a much better or a much smarter grid or a smarter scenario. I hope I was able to generate interest in buildings to grid integration in some AI-based techniques. I didn't go much deeper into what are AI-based techniques, because I was told that this is not a workshop. If you want a workshop, I encourage you, all of you, that we always organize hands-on MATLAB or the PSSE and Homer-based workshops, majorly through RE Connect. We develop that's a flagship program, which we do a 5-day program, which we do in a hybrid mode, offline and online mode, where we do the coding with all of you, and we also share the codes. There are certain lectures like this, and then we have workshops and codes in the same program, the Renewable Energy Connect RE Connect program. If you are interested, I request all of you to contact me, and we will definitely get in touch with you in order to give the program. The people will come from the industry, the people will come from MATLAB and OpenRT also, and we will be also sharing our research with you. Majorly how we can implement, I'll show you how we can implement one paper so that you get a good starting point, a takeoff for all of you. So I hope I was able to generate your interest in buildings to grid integration. Thank you all for the patient listening. I really want to thank sir and madam, the whole department led by the HOD for the Department of Electrical and Electronics, taking the opportunity to interact with all of you. I am extremely sorry that I was called upon for a brief meeting for convocation and I start 15 minutes late. Extremely sorry again, all of you. Thank you all for the patient listening. Over to you, ma'am. Thank you so much.
Thank you, sir, for such a wonderful information for all participants. Thank you, sir. Thank you very much. Hello.
Thank you.
Thank you, sir. We also thanks to all the participants. Next, day 5. The day 5 topic will be AI in renewable energy and integration, delivered by G. Rajshekhar, Associate Professor at KL University. Thank you very much.
Xin bỏ cho nó đi làm gì